Welcome everybody, good evening. It is my pleasure to introduce Ali Rahim from Contemporary Architecture Practice. Ali is a longtime friend of SCI-Arc and a longtime friend of many of us here. So in many, many ways, these conversations have been going on for 25 years already, which kind of reveals how old are we getting there. And also the new phases and new eras in the practice. So let me first cover some of the formalities. Ali is a professor of architecture and director of the Master Science and Design Advanced Architecture Design in Weizmann School of Architecture in the University of Pennsylvania. He's also director of contemporary architecture practice together with Hina Jamelle in New York and Shanghai. And on top of being an architect, a teacher, designer, he's a prolific bookmaker, monograph authorship, but also editors. So both Ali and Hina have an upcoming monograph called Catalytic Forms, which in many ways is kind of a almost 10 years continuation of catalytic formations. So there is a lot of catalytics going. And there is also a book that is also just to come out or has recently come out of Future Offices. But as many of you will know, he edited and co-edited some of them with Hina as well, many of AD issues that they were incredibly important to archive and organize and frame a particular periods of times of speculative work and research work, mostly through the digital tools, which at that time, it was much more a big deal about talking of digital. Some of the more recent one, it moved on beyond that. But talking about the work, because as I said, I think that it's not, I don't think it's an arbitrary thing that Ali and of course his partner and many of us navigate this Moebius territory between architecture, teaching, research, speculation, exhibitions, and so on, because it had to do with also a particular period of time that by now we take it for granted, but there was a particular time that these things were at the beginning, in the infancies, and everybody was trying to figure it out. What do we do with this? What are the mechanisms? How these relate with the larger trajectory in architecture? And I think the work that contemporary architecture practice and Ali and Hina figured it out is that there is a kind of, there are many ways to operate in this thing, but I think that one of the paths that they choose, and I think the main path that they choose is what I would call the coherent one, the species evolution. So the work has a continued resonance, they move to a project. So it's not that they look all the same or anything like that, but you can create a line from the most recent work to the beginning of the work, and you can see that evolution. That requires a high level of obsession and commitment and extreme precision and obsession for the idea of total design as well. So these are all mechanisms that the work has shown evolving. And I think one of the interesting challenges, and I think one of the maybe more relevant things to pay attention in the lecture today is how one goes to the territory where we speculate in an environment like this one, in this case in Penn, and how you scale up that into a practice that deals with clients and master plans and code and regulations and all that, and how you can navigate the back and forth between that, what needs to be kept, what we can keep, what we need to change. And in that sense, to me, it's fascinating to be part of to see that journey happening over the last 25 years from the beginnings where all these ideas were just really intangible, light things up in there, and now they're becoming, many of them get built, some of them on the way to be built, some of them going to a really massive scale, some of them are smaller, but they all have around the same obsession. So in a peculiar semester in which I think we have three lectures in a row with architects doing different forms of practices, it's an interesting one to have Ali Rahim talking about how they do it. And it is with enormous pleasure and happiness that we welcome Ali Rahim one more time to SCI-Arc.
Thank you very much, Hernán. It's a great introduction as usual. And it's really a great pleasure to be back at SCI-Arc. I mean, it's amongst friends, amongst longtime friends. Hernán just mentioned that. Yes, Hernán, Florencia, David, John Enright, you know, the whole Elena, Tom Main, you know, of course. We've been incredibly important for our speculations, but also in these venues to have friends who actually give you feedback on your work, right? And I think that is what makes being at SCI-Arc, being amongst friends, exciting, is that, you know, I look forward to receiving feedback. We keep moving. We never stand still. So I also just want to say a couple of words. I mean, none of this work would be possible without Hina Jamelle, my partner, who is in the audience. In addition to her, we have a terrific team at CAP, and I want to thank them for all the work they also do. So today, I really want to talk about seams as a way to get into our approach to making work, then expand it to some other topics. Architectural seams are where any two materials or elements come together. Seams, especially in digitally driven architecture, are often treated as defaults. They default to form. The way most digitally driven work is developed, there is a formal investigation, a big design move, and all the architectural details, tessellation, structural and material connections, and seams are derived from that process. I think that what we should recognize about this approach is that it promotes a certain architectural hierarchy in the design process. It privileges form over other key aspects of architecture. What we have been doing at CAP is inverting this formalist logic on its head, in particular by using the seam and detailing as starting points, growing them into larger tectonic and architectural systems. Working with the seam is a way to subvert conventional design logic, reinvigorate the detail in the architectural design process, and influence the implementation of new construction and fabrication methods. And that is what I call a catalytic form, a design element that accelerates changes in the larger architectural design and its context. I will now bring you through a series of our projects exploring this idea of the catalytic form at different scales and for different project types, looking at seams and details in each one. The first is Iwi Orthodontics, a 6,000 square foot VIP orthodontic clinic located in Omotesando, Tokyo, Japan. A vibrant and sophisticated area visited by both locals and tourists. The functional requirements of the project were complicated, and the clinic is situated in a neighborhood with stringent building codes. Our intention with these was to integrate the requirements and technicalities into a project with a coherent vision and elegant aesthetic. Within our practice, we are obsessed with intricacy, assembly, and materiality. We have always been interested in the role of the detail in the production of an aesthetic goal. Rather than beginning the project with a form and articulating it, we conceived of the project as a series of vectors wrapping the floor, walls, ceilings, and site, which are used to define detailed material connections and assemblies. By subverting the design process, moving from detail to form, we arrive at what we hope to be novel and unexpected solutions. Here is a detailed drawing of the orthodontic exam room. And this is the reflected ceiling plan of the clinic. The clinic is structured using steel and panelized with calcium silicate panels, free to move in the vertical dimension in case of earthquakes, that simultaneously operate as cavities for LED lights. The ceilings are milled calcium silicate panels that wrap the walls and meet more durable milled engineering wood panels. This is a mock-up of just a connection between the floor, the ceiling, as well as the LED. And as we move through, the seams are integrated with the furniture, which has the same form as the wall panels, but is made of soft foam wrapped in microsuede. So the spatial limitations that are characteristics of Tokyo in general were a determining factor in a strategy to increase the clinic scale by incorporating the exterior balcony into the interior space. And the seams in the balcony floor are porous to allow for the water to flow through the panels to the existing grain, which is at a lower level. The enlarged experience was achieved by adjusting the floor level of the interior and exterior balcony to be coplanar, creating continuity from inside to outside. And the interior ceiling also extends to cover more of the balcony, amplifying the extension of space. And here's the canopy drawing and details. And here are some construction photographs showing the canopy and balcony. We calibrated the design using a process that included all the technical and functional needs and allowed the requirements to inform and integrate into the final design. The result, the development of smooth and gradual transitions between materials, soft to hard, including paving, grass, soft paneling to fabrics, opaque to clear glass, and controlled LED halogen to natural light, while meeting the needs of the project. Our overall design intention was to integrate the complexities of the clinic, HVAC systems, lighting equipment, and space through a few key details, which when repeated and varied across the project, drive an aesthetic sensibility. The overall variation of the project is guided by proportionality, and the magnitude of variation is maintained within an aesthetic sensibility. The local limits of variation were set by the amount of variation necessary to have a different experience in each clinic. Sinuous lines map the culmination of the two limits set to variation. While the white color allows the pattern to be seen most clearly and is animated by the color of the sun through the day and night, month and season. And if you are familiar with Tokyo, the building in the back is the H&M headquarter building. So it's just adjacent to that street and location of H&M. So what happens is that this allows for each experience of visit to the clinic to be a new one for patients and diversifies the space for daily workers. As the patient travels towards each private clinic, the experience is designed to be more intimate. It compresses, and the patterned glass containing multiple opacities shimmers to create an atmosphere similar to a wall of trees with the leaves moving in the wind. The only light comes from the adjacent spaces, which helps animate the space through reflection and transmittance. The atmosphere is stimulating, yet comfortable, with green glass used for the interiors and incandescent light, which softens the experience. Here, I think you can see quite clearly the power of the seam. It can absorb all sorts of complexity, from material transitions to lighting, to embedded utilities, to seismic tolerances, and more, while driving the aesthetic of the project. This alters the logic of hiding all the necessities of architecture under the smooth and seamless form in favor of embracing complexity in the end result. The next project I'm going to share with you is CTTQ, which is a pharmaceutical company in Nanjing, China. It's a headquarter building for them. Seams play an integral role in this project as well, but at larger scales. Our design for CTTQ which is kind of a complex that sprawls across 6 existing buildings and 1.5 million square feet to diverse functions, including an educational center with auditorium, research and development facilities, laboratories, corporate offices, meeting spaces, including VIP and boardrooms, and a cafeteria that feeds 1,000 employees a day. I will focus on how we use seams to connect and nest discrete interior architectural elements within and across the existing envelope. In approaching the project, we conceived a series of details and developed them into tailored forms. These forms are disjunct from one another, but connected through various independent devices such as floor seams and ceiling patterns. Spatial divisions created by the interrelated forms break from the orthogonal column grid of the existing architecture. As such, the construction of the building may be the same throughout, but the aesthetic goals, details, and material assemblies shift as needed. We use different methods to achieve our goals, including the development of details that conceal or reveal edges and joints. Details are crucial as they control the aesthetics of the material assembly and form. Seams accentuate or diminish the assembly. Materials nest into and layer on top of one another. Details are developed into objects, and these objects are instead inserted into specific spaces. The exact techniques of assembly vary, but the goal is the same: to achieve a visually cohesive aesthetic composed of details that are both different and disjunct. This goal was achieved in 5 ways for CTTQ. The interview booth, for example, uses 4 disjunct materials at different scales. Seams move across materials and material assemblies instead of delineating them. White corian is nested into a frame of engineered wood. The booth is nested into a cove in the gypsum board ceiling. A gray composite is layered over the surface with an LED edge that makes it appear to float. The cove's interior is wrapped with engineered wood that connects to the engineered composites of the booth frame, but also acts to conceal the lighting and mechanical systems. The composite material reappears in the interior of the booth as a sound absorption material. The continuity of the booth is achieved through seaming details. The seam is indifferent to changes in materiality. I think that's really crucial in this project. It moves from the gypsum board ceiling, wraps around the engineered wood and gray composite of both walls, and continues to the carpet covering the floor. The reception desk has the same material palette as the meeting booths, but is configured differently. The details of the reception desk reinforce the aesthetic theme of the project. materials nested into one another, revealed through precise detailing. And what is resultant is that the overall mass of the desk is set in contrast with the lightness of the engineered wood paneling and enhanced through a concealed LED around its edge. The thin 3/8-inch corian cradling the engineered wood intensifies the relationship of the wood to corian itself. Seams are also used to separate the same materials in different ways. For example, in the gallery space for exhibitions of CTTQ's products, the seams of the ceiling move across the seams of the assembled glass fiber reinforced panels. So the assembly is in one direction, the seams cross the direction to remove the knowledge of how it was built and constructed. The ceiling and floor details produce a floating effect, giving the space a light and soft yet tailored quality. And the resultant is what you see here. There are clear moments of continuity through the curvilinear geometry, but also moments of discontinuity where the walls disrupt the flow paths and create moments for display and observation. The ceiling wall connection details are key to the disjunctive quality of the space. 4 walls delineate the gallery space, each of which has a nested backlit display box and acts as a gallery display space. The section of the ceiling has 2 mirrored adjoining fillets separated by a distinct groove, which creates a shadowy transition between the wall and the ceiling. This, along with the flush lighting detail, its adjoining seam, and a larger concave section of the ceiling reinforce the nested quality of the gallery walls. These details work to both emphasize the walls as individual objects inserted into the space and enhance the performance as exhibition areas. Here is the same idea manifest in engineered wood. This is actually a view of the boardroom. And in this instance, the seam and its relation to the indentation actually layers the wood as opposed to carves it, as in the panels in the space outside the VIP room, which is the gallery space we just discussed. And now we move to a very important part of the project because it's the connector between a lot of different spaces. And here, the seams scale up to form monolithic volumes nested with different materials. The stair that connects the main lobby to the training center is a large monolithic form, prefabricated off-site in one piece, and then installed in the space. The handrail is carved into the interior of the form, as can be seen in this mock-up image. Three seams of varying widths located on the ceiling enhance the form's presence in the space. A fine seam of 3/16 of an inch highlights the opening of the stair. A wider seam of 3/4 of an inch masks linear diffusers, and the largest seam of 1 inch houses a light fixture that cradles the stair and nearby bench. Wood stairs are inserted into the interior of the monolithic form. There's a reveal designed on the edge of the stair for LED lights. And this you will see a little later, but it's an important effect that we're trying to achieve. Wooden bookcases are nested within and on the sides of the larger form. The wood profile on the perimeter of the bookcase is concealed in order to emphasize the nested quality of the wood. The stair and bench allow for the nesting of materials to amplify the space's larger volumetric qualities. The sculptural stair connects the training center to the main lobby and serves as one of the prominent design elements in the project. The stair was conceived of as form inserted into the project. This is reinforced through the flush light and the seam of the ceilings that cradle the stair. This is a view from the exterior, showing the stair design reflected in a pool of water that highlights the interiority of the project. Seams also shape spaces. For example, in the Research and Development Building, cast aluminum inset seams are used in the Research and Development Facility to separate the black and white micro-terrazzo flooring. These are mirrored by wide black seams on the ceiling, flanked by two finer black seams that contain lighting fixtures and linear diffusers. The floor and ceiling lines delineate the disjunctive office spaces and conference areas around them. The same aluminum floor seams are used to formulate the edge of the material change between hard micro-terrazzo and soft carpeting. The floor and ceiling seams shape the elliptical spaces around them and create a sleekness that is meant to reflect the progressive nature of the Research and Development Department. As the floor material changes, the ceiling lowers and changes in material from drywall to acoustic panels for open offices. And the micro-terrazzo floor continues and stops at the edge of the conference room, which is made entirely of flush abutted glass panels to accentuate its shape and object-like qualities. The glass conference spaces of the Research and Development Center are used to break up the open office spaces, and the slope detail around these spaces reinforce the reading of the glass conference spaces as forms nested into the ceiling. Finally, repetition of seams multiplies the material intricacies of the space. The auditorium is an accumulation of striated sections. Each section is detailed with engineered wood, acoustic panels covered in fabric, and drywall. And you can see, I want to point this out, and I try and keep teaching my students how precision is a key in the discipline of controlling an aesthetic. And so all of our work is geometred very precisely. So the long axis of the auditorium is shaped for acoustic optimization. The short axis has been broken down through material striation, moving transverse to the direction of form. The material striation is composed of bands of wood panels, fabric acoustic panels, and gypsum board. The drywall is flush with the gray fabric acoustic panels and abuts the wood panels. The scale of the gray panels is broken down by an additional seam moving vertically and parallel to the shape of the panel. The seams continue onto the ceiling, where the distance between them is reduced, and widened again, where they meet the panels on the opposite side of the auditorium. As the seams move down the wall and meet the floor, they continue and separate the hardwood from the carpet floor. This detail is multiplied 7 times and is highlighted by continuous strips of LED light. Each striated section is offset by the height of a stair. Each stair offset allows the ceiling to house lighting, ventilation, and acoustic components. Repeating the section 7 times creates the overall visual impact of the auditorium being spatially disjunct in longitudinal section, yet aesthetically cohesive in material composition. And this is a view from the balcony spaces looking back into the auditorium, and a lot of the VIPs actually in China inhabit this space. As a whole, the CTTQ headquarters design highlights how the detail can be developed and expanded across a work of architecture to meet a variety of programmatic and performance needs while cultivating an aesthetic that is at once cohesive and curated. While the nuanced program of the project lends itself well to this architectural approach, its greater disciplinary value is not limited to this context. When considered more broadly, the strategy can be used to rethink and create new approaches to larger scale projects in terms of construction, aesthetics, and typology. One specific area of interest we have been invested in really for complexity and modularity is urban housing, as explored in this project. With a fresh focus on the detail, architecture can move from intricacy of assembly and nuanced spatial design to the creation of whole new architectural typology and construction workflows, or the reconfiguration of existing ones. So we were asked by Samsung Construction and Technology to formulate an 18-building master plan along the Han River in central Seoul, using predetermined building types initially created for their housing designs. The challenge was to create significant differences between buildings across the master plan while maintaining specified building forms. This is in strict contrast to the monotonous and impersonal 20th century mass housing developments that typify mass housing in Seoul. We had several constraints, including zoning codes, unit sizes based on tax codes, and the need to create a unique facade for each building. In the spirit of aesthetic intervention, we sought to use a highly graphic and variable facade strategy with a deep investment in architectural performance to reconfigure the typology. A novel approach of detailing and prefabrication was essential in this respect. We sought to create a design sequence that breaks with the homogeneity of the original housing design while enhancing its attractiveness in terms of cost effectivity and construction efficiency. As in CTTQ headquarters project, this project is developed at several scales. The project seeks to achieve a visually cohesive aesthetic composed of details that enable different performance and programmatic criteria. This was accomplished in multiple ways, ranging from facade details to the overall master plan. To start, the facades are composed of 10 unique prefabricated frames, each with its own architectural detailing. Frames sit flush, are recessed, or protrude from the facade. The edges of each frame are either wide, narrow, or bend and become an angle. Some frames contain a seam, making them appear bifurcated. Other frames sit adjacent to, on top of one another, creating a reveal between frames of different widths. Multiple frames are also grouped together in larger frames to create nesting effects. Further, the materiality of each frame changes depending on its width relative to other parts of the facade. If the frame is extremely wide, a seam is carved into it to give it a narrower reading while visually reinforcing the metal on the facade. When we group multiple wider frames together, we use metal as the facade material, making the building more opaque. At the other extreme, we use very thin frames assembled next to each other to develop the most transparent parts of the facade. As frame oscillate in width, the glass to metal ratio is altered, which is aimed at giving an overall sense of cohesion and aesthetics to the building. Frame components and glazing articulate movement across the facade to enliven and enrich the generic form of the building footprint. All of these different facade arrangements and material transitions are enabled by a single detailing and design system. The frame components work well within the limitation of Samsung's production and manufacturing techniques. The knowledge set the limits of the amount of variation possible, yet allowed for a tremendous amount of customization in each building. By integrating and optimizing the frame design with prefabrication processes and limitations from the outside of the project, we were able to achieve cost-effective mass customized results. The typology here, because of the need for repetition, actually opens up an opportunity to push forward new design processes with the effects for both the housing typology in terms of new configurative and performative capacities, as well as manufacturing and construction in terms of implementation of new technology. By asserting mass customization at such a large scale, architecture can put pressure on the construction industry to implement technologies that it might otherwise be slow to adapt. Instead of one detail, there are 10, which even in the public housing context realm is a readily achievable system. Because there are not one, but 18 buildings, the project is able to achieve an economy of scale. The typology provides a scenario for adapting an automotive model of manufacturing to housing. Customizable options at different scales can be swapped in and out while maintaining a basic design system and processing line. This creates opportunities to vary materials in ways that enable higher level performance, whether programmatic, phenomenological, or environmental in nature. By prefabricating components and assemblies in off-site manufacturing facilities, agency and expression are given back to multiple stakeholders, to the city in terms of aesthetics, builders in terms of how they work, and residents in terms of the feel and the quality of their homes. Variations in framing details are echoed in larger scale configurations of units and relations between buildings throughout the project. For instance, with only minor alterations to the core and chase locations, we transformed the unit organization from a static repetition of residential units into dynamic layouts with enough flexibility that they can change and plan location as needed. So the buildings here then adhere to strict regulations, including unit size while maximizing the amount of variation of views and interior space within planned configurations. Configurations were determined primarily by the locations of vertical building systems, including circulation as well as dry and wet shafts. In some cases, there are living rooms in the corner of the buildings, and other times there are bedrooms. Also, the locations of one-bedroom units and two-bedroom units changes, mediating between efficiency of layout and quality of space with views. Starting from two types of units in the F, which is the flat type building, we created 6 variations across each building. These unit types were developed per building, and their locations in the plan correlated to core and shaft location and design. Plan configurations also shift across multiple buildings. In particular, unit configurations correspond to the proximity of adjacent buildings to create a dialogue between buildings and maximize both views and privacy. The location of chases provides us with opportunities to alter kitchen and bathroom layouts, maximizing views for each residential unit. In sum, the tectonic design gave Samsung flexibility in how they located units. The interaction between the facade and the variation of units developed nuance for each residential unit in orientation, elevation, and window performance. The facade brings in light in different ways, frames specific views, and makes strategic areas of the unit more opaque or transparent than others. The combination of strategies gave us 64 units per building, right? Different plans, the 64 unit plans per building. This enables the resident to select from a menu of features for each unit, as well as height above the ground, unit orientation, unique window features, and views. Each unit affects the location of the layout of the building next to it. This produces a master plan with a look and feel based on floor-by-floor regulations and repeatable customized components rather than generic mass-produced building-to-building relations. The plans and elevations appear disjunct, yet they are tied together by the underlying tectonic and aesthetic logic of the building as a whole. Our strategy was to use these constraints and develop the most efficient master plan possible, tying the discontinuity between building forms together with landscapes of similar elements at different scales. The master plan then incorporates all the programmatic and zoning codes required to maximize views and quality of light for mid to high-rise development. We reassessed the value of a large central recreation area for the entire community and developed several micro-community recreation areas around smaller zones. This reflects the effort to create more localized architectural moments in the facade and layout design. The micro-community areas likewise acquire their own particular qualities and identities in relation to the building and landscape variations around them. The project recognizes that certain efficiencies and building construction workflows are needed to meet the pressures of urbanization, affordability, and densification. It shows that deeper understandings of typology and its material and social performance can be achieved by engaging it with more intelligent and nuanced design systems and procedures that are centered on the detail. It allows for a diversity of localized architectural experience and individual expressions of identity, while putting forward an overall expression of technology at urban and global scales. Further, with a 21st century approach to prefabrication and details, incessant repetition that leads to monotony in architecture and urban life can be replaced with the heterogeneous assemblies that enable a range of experiences and activities. This implies a turn toward design approaches which attune prefabrication processes to variable tectonics. A reinvigoration of architectural detailing as a generative tool, and a new synergies between aesthetics and performance. It instigates new graphic or aesthetic conceptions of architecture invested in building performance. In this next project, I'll just get there, excuse me. In the next project, designed for a high school in Shenzhen, China, we used some of the same detailing strategies from the facade design in the Samsung Housing Han River Master Plan, but deployed them in a horizontal building type that integrates closely with exterior space and landscape design. Shenzhen 24th High School is a 904,000 square foot educational facility and landscape design in Shenzhen, China. Due to the temperate nature of the climate in Shenzhen, the classrooms are able to be consistently engaged with the landscape. The project seeks to engage architecture more directly in the act of education. It presents students with a kinetic architectural language that makes no reference to a traditional school typology, but rather looks elsewhere to encourage student inquiry and provoke curiosity. We explored the hybrid territory of a site wherein building and landscape is perceptually interchangeable. Much of the circulation, instead of being located on the interior of the building, is pushed outwards to open-air terraces and building bridges, which simultaneously serve as shading strategies and canopies for adjacent spaces below. This type of constant interfacing with the outdoors provides a contrast to normative typologies where students are expected to be inside all day until lunch or physical education times. The site plan defines clusters of semi-independent academic building units that each integrate a full curriculum segregated by a plinth level to foster team teaching in a more intimate educational setting. A row of interlocking forms are set on one side of a long central street, which cuts through the campus and serves as an organizational element. Seeking to create a counterpart to the suburban context, the sense of urban experience is intensified by the compression of the street, which leads you to the athletic and residential campus on one side, while it moves you to the STEAM building and amphitheater on the other. We formed the main 6-story academic buildings on an east-west line and then connected them in areas to create more intimate space for the outdoor classrooms and to maximize light in the classrooms at different times of the year. The project applies a prefabricated steel system. It utilizes 2 different structural systems, box trusses and a regularized grid system to achieve different purposes in the campus. In the academic buildings, the bars, In the academic buildings, the bars are primarily structured using box trusses, which are the most efficient structures to span slightly longer distances in buildings. All members are standardized and are erected off-site and on-site easily. A building bar consists of 3 layers of structure: a main grid structure, main truss structure, and secondary filler beams. All floors are made of prefabricated composite slabs. The entire structure sits on pile foundations at the base for all the buildings. The south side of the academic building includes an exterior hallway. The 2 meters wide hallway provides a deep shade for preventing direct sunlight. On the south facade, we provide 6 types of prefabricated units that can assemble with standard floor ceiling and glass to provide different facades to respond to the interior program. And the north sunlight provides the best natural lighting source for the academic buildings. To obtain the most amount of sunlight, there are 4 types of prefabricated units that assemble with 2 sizes of horizontal operable windows according to the interior programs. The north facade is open with more glass to provide soft indirect lighting for study spaces. The dormitories are created to formulate a clustering of residential buildings that frame the athletic facility and allow for maximum light at different times of the year. The faculty dormitories towards the south are 8 stories and lower than the 12-story male dormitory, while the female dormitory on the east of the site is 13 stories tall. The dormitory facade features a simple and effective system that forms an essential look of the campus. The facade is modularized into 4 types of units, and the dormitory complex is the tallest building on the campus. The whole structural system uses the most common and efficient steel grid. Additionally, the interior and exterior are designed to achieve the goal of 100% prefabricated assembly. With the same site condition, the dormitory complex also uses pile foundations as a base for all the buildings. The landscape features bring all the different parts of the campus together, working with the existing topography in addition to providing shifts in terrain heights to facilitate stairs that become seating areas and provide for programmatic flexibility. And here is that corridor that I mentioned earlier in the talk. This is the hallway on the south side. The multi-level design of the landscape creates various level and edge conditions across the site to meet the needs of different programs. Stairs connecting the plinth level to the track, raised planters, and edges of water features to sit on, in addition to stairs for each landscape courtyard, are facilitated by the wide stairs that allow for students, teachers, and administrators to sit and lounge on them as they wish, including meeting for classes or reading. The bridge above creates intimate courtyard spaces below because it provides a shadow buffer between the spaces, so you can have multiple classes meet at the same time. Landscaped outdoor teaching areas act as courtyard buffers between buildings and punctuate the classroom units with views of plantings and sky. Overall, I hope the project shows that a contemporary approach to detailing and material assembly in a cost-effective manner applied to a deeply ingrained typology can impact the architecture and the types of social interactivity that characterize education more generally, or other sectors for that matter. For the next project, Tencent headquarters, a 2.7 million square foot headquarters building in Xi'an, China, we wanted to shift the scale of the generative aesthetic techniques in the previous projects to larger, multi-building and urban scale assemblies and organization. Xi'an is notably dusty, I mean, if you've ever been there, and also home to the terracotta warriors. We wanted to create something striking and resilient to serve both the identity of Tencent's brand and the character of the city. The project features 3 levels of retail embedded in the ground floor plinth, 2 residential towers, 2 office towers, and a large tower split between office and hotel spaces, all spread over an entire city block. The integration between programs was challenging and required an innovative approach to create a cohesive design and produce a unique landmark for the region. Here, macro-level seams from the building's forms run across the site, delineate shifts in program, most notably on the ground. They expand into terraced large atria carved into the plinth, which provides light, air, circulation, and thresholds between indoor and outdoor spaces. As one moves around the building and its urban context, the forms are meant to change their expressions, creating a unique and dynamic project from every angle. The formal opulence of the building is constituted by creating a genealogy of formal features that are once distinctive yet interrelated. The detail of the terracotta panels, in contrast with the aluminum edge, heightens the dynamism of the form when illuminated with sunlight. The detail also provides the disjunctive nature between the buildings without compromising the overall brand aesthetic for a world-leading high-tech company. And if you are familiar with Tencent, or if you communicate with any Chinese students, you will realize that Tencent is the owner of WeChat and a very powerful company indeed in China. The facade detail wraps around the building volumes, changing width and direction in accordance with shading needs, program delineation, and circulation strategies. At times, the detail expands outward to create terraces on the building faces. The repetition adds dynamism and variation to what could be otherwise a monolithic and imposing site. At multiple points around the perimeter of the base, the volumes press inward to create access points and green spaces. These are often shaded by portions of the base that cantilever outward on upper levels of the plinth. This is looking from one of the spaces below up the project. Across the site plan, courtyards are formed starting from different levels by the expansion and contraction of the volumes and seams. The courtyards provide light, exterior accessways, terraces, and green spaces throughout the interior of the project. The aim is to provide a diversity of outdoor spaces in terms of size, spatial quality, and program adjacencies, which inflect the interior with difference and a sense of discovery as one moves between different spaces. Overall, the contrasting width of panels, their shifting dimensionality and directionality, their environmental performance, and their aesthetic impact show how a detail-forward approach and focus on seams can be used incessantly to invigorate the life of a project, whether experienced from up close or far away. And the discontinuity comes from the actual shimmering of the metal edges on the terracotta panels, which are illuminated by the environment and the sun, etc. So depending on what view one takes or looks at this building from, it provides a completely different orientation with regards to the disjunct shimmering of light on the terracotta panels, which are completely opaque and they soak up the light. So the contrast is really crucial. Now I'm going to turn to our winning design for Lijia Smart Park, 126-acre development in Chongqing, China, which is currently under construction. In Lijia, all of the techniques from the previous projects come together in a multifaceted master plan. Chongqing is a subtropical city with a beautiful natural location set among dramatic mountains and the intersection of the Yangtze and Jialing rivers. The site of the project is a microcosm of Chongqing with its steep hills and large topographic drop to the Hongzai Park. The project comprises two sites adjacent to Hongzai Ecological Park and surrounding the Hongya Reservoir, which is in the center of our site. The smaller site shown here to the right is currently under construction and includes a subway that is actually running right through the site, which you can see. Calligraphy was used as an inspiration and aesthetic device for organizing the site. The calligraphy lines in the master plan traverse, turn, pause, lift, press, and outline. The calligraphy lines register keynotes of circulation, common areas, and building forms. This allows the project to develop a sense of place and has meaning nationally as well as globally. The master plan itself consists of 13 buildings on a plinth that connects all the buildings together into a cohesive form. It includes 8 office towers, 4 research and development buildings, and the centrally located Big Data Museum. The green connection is important to the cohesion of the overall master plan vision. It contains landscape features with hard and soft surfaces, seating areas, plazas that establish an impactful urban experience for all the people who work and visit the area. It is achieved through careful coordination of surface textures, detailed transitions between softscapes, hardscapes, and building forms, a unitized paneling system in the towers, and repetitive design elements. Here you can see how the vertical detailing of the calligraphy motif on the building facades work together with the circulation paths across the site to create a cohesive architectural language. The sinuous nature of calligraphy decentralizes collective form making. Spatial and performative variations spread across the site for different purposes while maintaining a sense of collective identity and place that is simultaneously decentralized and dynamic. The morphology of the project responds to the dense gridded city to the north and the park to the south. Along the north edge are 8 gridded high-rise office towers that undulate in plan and in section. The south side consists of interconnected terraced buildings and landscapes that respond to the soft edge of the lake and Hongzai Park beyond. The towers all use the same construction methods and details. However, great variation is achieved by keying specific details into different parts of the site. The tower facades are designed using white frosted glass with minimal details and are highlighted with brush strokes of dark translucent glass. The dark strokes are offset from the facade surface to create a greater sense of depth and articulate programmatic shifts, and the carving is 3-dimensional and sculpts into the interior of the project. The calligraphy strips of glass that are dark during the day and illuminated at night break up the continuity of the surface and reduce the perceived scale of the building facades so they reflect the overall context of the master plan. Chamfered edge details on the floor slabs add to the sense of overall lightness in the structure. The window panels are all identical, but the design of the frame detail allows them to rotate in multiple directions. This enables the creation of variable surface textures and geometry, and it allows for the fine-tuning of environmental performance criteria. These breaks in form are carefully coordinated and detailed with the unitized paneling system. The repetition reduces an overall elegant effect where the large-scale surface disruptions acquire an organic feel and flow. This adds lightness to what otherwise would be an imposing form and creates a tremendous amount of surface differentiation and elevation in terms of texture, light, and composition. The opening in the entry frames the lake and is highlighted with the digital advertisement that highlights the cutting-edge nature of the project and serves as a gateway for the entire Western District of Lijia. The steep topography of the site is integrated into the multi-level design of the plinth. The levels are interconnected through circulation mechanisms, including stairs, escalators, ramps, bridges, and smart vehicle paths. We have smart vehicle loops all through the project. The surface texture of the facade spills out onto the landscape through material transitions. Seams are used to transition between lighting, benches, landscaped areas, heart-shaped patterns, and more. Pedestrian circulation is the central feature of the site and its interconnectedness. The first loop around the lake, the second loop connects retail spaces, plazas, and landscaped areas. This creates a multi-centric plan with multiple courtyards. The 215,000 square foot Big Data Museum sits at the nexus of the calligraphy, wrapping the site, and serves as the brain for the smart city. The smart systems of mobility, utility, communications, and infrastructure are integrated in the building. As one enters the museum, the progression up the building reveals the exhibits. The crowning moment is the skylight that brings in natural light. A key component of the museum is to show how the smart city works through the central control center display, while the perimeter features incorporate cultural components. The edges of the building are lifted to reduce the mass of the volume. It is cantilevered and features a large-scale LED screen fitted to the form on the underside. This can be seen from the subway and throughout the site and gives passerbys a glimpse of the interior and attracts visitors. Like the other buildings on the site, the calligraphy is carved into the facade, adding surface depth and variation. These also feature additional large format LED strips. The surface of the building is clad in metal strips whose seams create a sharp and distinct texture with its own shimmering effects. We multiplied the seams 7 times in CTTQ for the auditorium. We multiplied it 150 times to the surface of the Big Data Museum. So the seams, again, begin to really enable sort of a reading of this soft surface just because of how much detail it has in it. Chamfered edges in the canopy overhangs reference and culminate in the form of the building. The whole large site cross-references and integrates seams and chamfers to reduce the visual appearance of the plinth levels. Don't worry, we're close. We're close to the end. The texture of the building as a whole strikes a contrast with the surrounding panelized towers, varying experience of the site as one moves throughout. Overall, the interplay between textures, seams, and repeated assemblies across the site show how working at a small scale, moving from detail to form across the master plan, creates unexpected synergetic spaces. What I want to emphasize in these projects is that the designing of the detail puts a tremendous amount of power back in the hands of the architect. If we just focus on form and leave all the devilish particulars of how to put a project together to software default and other disciplines, we're not taking full responsibility for what we create. Without a robust stance toward assembly and materiality grounded in the disciplinary issues, architecture shaped by new technology will become irrelevant. You could probably argue it already is. I think our projects demonstrate how a rigorous investigation of seams and details can be fruitful starting points for initiating a project. The method can yield striking results at multiple scales, whether in defined connections between interior wall panels, nuanced material transition in assemblies, innovations in facade detailing, reconfiguration of existing typologies, macro-level site contouring and definition, or in urban scale master planning. Moving from detail to form also fosters new collaborations with manufacturers and fabricators. It puts a productive constraint in the design, which also ensures quality all the way through the construction of a project. It keeps us focused on creating something novel, and by doing so, restores potential in catalyzing new social, cultural, and environmental forms. Thank you very much.